maybe our obsession with time is not just about it passing and not being able to control it and that kind of neuroses. Maybe our obsession with time is there because we truly wouldn't have a sense of self without it, and what's more important than a sense of self? I received a comment on a previous video saying, I would like to understand the infatuation that physicists have with clocks. Ever since Einstein popularised thought experiments, every cosmological discussion appears to devolve into, let's say that we have a clock here and we have a clock there and blah blah blah. Brian Greene made an offhand remark claiming that somehow Planck and Einstein's field theories somehow mean that anything with mass is a clock. Did I hear this correctly? Am I a clock? In this video, we are going to talk about why some physicists believe that everything is a clock and our kind of evolving theory around time, why we're so into it, why it matters, and hopefully by the end of it, you'll have a pretty changed view of time, or at least some cogs will be turning in places you didn't think they could turn. Hello, welcome to Brain Noises. I am Chloe, science communicator and recovering physicist, and on this channel we talk about the thoughts that pass through my mind, generally relating to science, but I cannot make any promises. So if you think that's something you might be interested in, then please subscribe, like, comment, shout it from the rooftops. All of the above. Einstein once said, time is what clocks measure. But in 2013, physicist Paul Oerker, a master's student at the time, decided he was pretty dissatisfied with this idea. I mean, the idea in itself was fine, but the way that physicists dealt with clocks was something that he just felt was incomplete. He found that physicists, though obviously really into time, hadn't really bothered to think much about the fundamentals of timekeeping, about the fundamentals of clocks. They tended to take this kind of information for granted, so he decided to look into what it means to be a clock and what a clock actually is. And over the past few years, through studies of the simplest conceivable clocks, physicists have tested the bounds and established a few of the limits of timekeeping, exploring new relationships between accuracy, information, complexity, energy, and entropy. Entropy is the quantity whose incessant rise in the universe is closely associated with the arrow of time, an idea that I talked about quite a lot in my previous video, Why Physicists Can't Explain Time. And these relationships were purely theoretical until a year or so ago, when physicist Natalia Aries and her team at the University of Oxford reported measurements of a nanoscale clock. So what is a clock then? One of the first things to note about this new thermodynamic theory of clocks is that pretty much everything is a clock. Rubbish announces the days with its worsening smell, wrinkles mark the years. You could tell time by measuring how cold your coffee has gotten on your coffee table, says physicist Marcus Huber. Oerker and his colleagues talk about how a clock is anything that undergoes irreversible changes in which energy spreads out among more particles or into a broader area. And energy tends to dissipate, and entropy, a measure of its dissipation, tends to increase. Not only do energy's strong spreading tendency and entropy's resulting irreversible rise seem to account for time's arrow, but according to Huber, it also accounts for clocks. The irreversibility is really fundamental, Huber says. But coffee and rubbish don't make good clocks. As with most irreversible processes, they happen stochastically, so randomly. So in order to estimate a time interval, you have to average what is happening over long stretches of time to allow for all the random collisions to kind of even each other out. But what the researchers realised is that we don't call rubbish and coffee clocks because this name, the title of clock, is reserved for objects whose timekeeping ability is enhanced by periodicity, the mechanism that spaces out the intervals between the moments when irreversible processes occur. A good clock doesn't just change with time. It ticks. It marks the beginning and the end of each period of time. And the more regular these ticks, the more accurate the clock. This idea does actually feel quite logical. In their first 2017 paper, Oerker and Huber and co-authors showed that better timekeeping does come at a cost. The greater a clock's accuracy, the more energy it dissipates and the more entropy it produces in the course of ticking. A clock is a flow meter for entropy, says Milburn. They found that if you have an ideal clock, so one that ticks with perfect periodicity, it would burn an infinite amount of energy and so then produce infinite entropy, which isn't possible. Thus, the accuracy of clocks is fundamentally limited. And I found this idea really interesting because it's very reminiscent of the uncertainty principle and this idea that like there's a limit to how much stuff we can know about something, how the position and velocity of an object cannot be measured exactly at the same time, even in theory. And their research touched on this idea even more. Urquhart and company studied the accuracy of the simplest clock they could think of, a quantum system consisting of 3 atoms. I'm going to link this paper in the description if you want to read more about it, find out more details. But essentially it revealed that there is a deep connection between entropy and information. Any limit on a clock's entropy production should naturally correspond to a limit of information, including, Huber said, information about the time that's passed. Another paper was published that year, again linked in the description, that increased the complexity of the system, and by adding this additional complexity it allowed them to concentrate the probability of a tick happening into a narrower and narrower window, thereby increasing the regularity and the accuracy of the clock. And so it's the irreversible rise of entropy that makes timekeeping possible, but it's the periodicity and complexity of the clock that increases its performance. So maybe rubbish is a clock, it's just a really, really bad one, a really, really rubbish one. Sorry. But yeah, until it all really kicked off in 2019, it wasn't actually clear how to verify the equations, and it also sort of wasn't clear how quantum clocks were really related to the clocks that we see on our walls, on our wrists, on our phones. So when considering the comment that I mentioned at the beginning of this video and when looking into the topic, a few thoughts popped into my mind, and maybe I'm just deeping it or like thinking about it too much, but I'm really interested as to what you guys think about the following ideas. My main thought is a bit of a chicken or egg one. Are we obsessed with time because of its importance in almost all of our physical theories? Or is time so important to all of our physical theories because we're so obsessed with it? With all this stuff about time, I just can't help but think about like a type of confirmation bias, I guess, and this idea that like you find what you look for. If you Google a question, the answer is more likely to confirm what you already believe, or at least what you're looking for, because of maybe the way you phrased it or your previous search history. Because there's no such thing as true objectivity. Even in like physics experiments, we construct them to try to create as much objectivity as possible, but even just like the fact we're looking for this particular thing kind of removes the pure objectivity of it. And translated to physics, it's a case of like maybe we keep coming back to this idea of time and looking into it and like exploring the mysteries around it because we are subconsciously or consciously just like acutely aware of it passing as humans. And I think I'm entertaining this idea because it makes sense. Like, obviously humans would be really quite obsessed with time because we have such a limited amount of it. We are immortal, and when it comes down to it, I think time is actually one of, if not the most powerful governor of like all of our behaviours, which I think already is enough to fuel an obsession with it. But on top of it, and I think another part of why we're so into it, is because it's so difficult to conceptualise it. Not only is it constantly passing, but unlike speed or length, we can't really see it in the way that we can with those things. Like, it's quite a slippery thing. It's ever present, but it's also really hard to pin down. But at the same time, it's like ever passing, and at least currently is completely out of our control. You know, like time marches on no matter what. So to us, it's constantly moving forward. But then equally, like, it's really hard to really be in the present. Like, the present just feels like what happens after the past and before the future. So I think this lack of control element is another part of what really like fuels our obsession. But then again, maybe it's both. Like, maybe these elements that I've just mentioned are a part of why we're obsessed with it, but maybe it is also kind of worthy of that obsession and the mystery that surrounds it. And maybe even without us being like super obsessed with it, it would still be a really core part of a lot of our theories in physics. Legs gone numb, it's that part of the video. It's actually so weird, limbs going numb. Sorry. And maybe like the lesson here is, or at least the like lesson as just an everyday person as opposed to a physicist, is to lean into the abstraction of it and maybe even kind of use it to our advantage. So there are ways to savor time, to use it wisely, to live in the moment. And though technically you're not giving yourself, sorry, I'm actually gonna have to move position because God, I feel like it's a really dynamic video this week, sorry. So yeah, although through these methods we're not technically giving ourselves more time, from our perspective it feels like we do have more time because we're savouring it. And like at the end of the day, our perspective is what we see the world through. So like, does it even matter if we technically have more time, or whether it just feels like we have more time? And I understand how, like, to physicists this distinction matters, but to just regular people like living their lives, it's an interesting thing to consider. And an example I often think about, and I've like seen spoken about a little bit, is how the classic, when we're scrolling through social media, you can be doing it for like half an hour, several hours, and you sort of come out of it and stop doing it. And though a really significant portion of time has passed, it often feels like you can't necessarily even recall like anything you watched or anything you learned, or at least just a very little of what you watched and learnt. And I think that's a really good example of like the inverse of it. Like, if you're not properly engaging with time, it can feel like no time has passed and you're just completely like plugged in and zoned out. And then by contrast, like, studies have been done that talk about how when something unusual happens or something interesting, time actually in our heads slows down. And it's why people talk about like when accidents happen, it feels like they're moving in slow motion. Like, this isn't just a kind of fluffy way poets talk about it. It's like something that actually happens when you're processing memories. Like, it will feel like more time happened in a small space of time. And that is reflected in like this slow-mo effect. So the way I sort of ended up seeing it when I was down this quite deep rabbit hole is that time passes in these clear packets. Time passes at the same rate, but it's kind of up to you to like actually collect these packets as like moments, as memories. And yeah, there are just like so many things in physics that feel so slippery, so weird, entanglement, etc. But it feels like nothing is quite as slippery as just like understanding the present and like trying to live fully in it. Oh wow, the light has really changed. I feel like it's really glowing on me now. Okay, I'm moving back into position. Okay, leg has denumbed. And finally, in that vein, and kind of like harping back to the beginning of this video, so how does our awareness of like time passing, our access to clocks, the sun, like how does that affect us? Getting rid of clocks and just using the sun to guide you has really positive like health benefits. But an article that I read recently spoke about how when you lose any sense of time whatsoever, you risk losing yourself too. So experiments where they've stripped people of any like natural indicators and man-made indicators of time passing have really caused people to kind of lose their sense of self in quite a remarkable and like severe way. And so finally, maybe our obsession with time is not just about it passing and not being able to control it and that kind of neuroses. Maybe our obsession with time is there because we truly wouldn't have a sense of self without it. And what's more important than a sense of self? Anyway, on that cliffhanger, wow, this video became a lot more intense than I thought it would. But we've come to the end of it. I hope you enjoyed it. I hope you learned something. Yeah, as I said, really interested to hear what you think of these thoughts, whether this is some kind of screaming into the void, crazy spiral, or whether it means anything to anyone. Thank you for watching. I will see you in the next one. Goodbye.